Hello guys, today I'm talking about the pyramids, cones, and the spheres. Okay, we're just talking about three different volumes and the surface area. Okay, so first is about pyramid. Okay, so about the volume of pyramid, we can say that it can be written as 1/3 times the base area, then times the perpendicular height. Okay, so we can just consider that the pyramid like this shape. Okay, just like a real pyramid shapes. Okay. And you can consider like the base area as a rectangle, sometimes also a square, okay. And the height means from the turning point, then you draw a perpendicular line to the base, okay. That is a height h, okay. So we can say the volume here is 1/3 times height times the base area can be considered as a rectangle's area, like A times B, or like some others, okay. That is pyramid. And second about the cons, okay, so we can say the cons here also very similar to the formula as before as a pyramid, right? Okay, 1/3 times the base area is times the height, okay? So you find for the cons, the base area always be a circle, right? So the circle's area can be written as pi r squared, right? So height is h, so we can say that the volume of the cons is 1/3 times pi r squared then times height, okay? So we can say here, h is a perpendicular height, okay? That is very important for you to understand for all of this, okay? And then we comes to the cons for surface area, okay? So we can say like maybe here that is a cons, and here is a base area, and we knew that here, sorry for that, okay? Sorry for that. And here we can consider that here, the length means here, that is like the slant side, okay? Or slant height. And we can say here's r, here's height. We can say that the length of it is length equals to square root r squared plus h squared, okay? Follows the rules of the Pythagorean theorem, okay? And we can say here, the curved surface area means when you want to expand this, it can becomes first is sector, and then is a circle, okay? So you can find here, the sector, we have the length here that is like 2 pi r, right? 2 pi term radius, and then there is length L. And you can just trying to consider it as a triangle. Okay, the triangle's area's formula is a half times height times base, right? So here is also the same, like a half times height is L, like here. You just consider it as a triangle. So here the height is h, that is L, then times 2 pi r, okay? 2 pi radius, okay? That is it. Okay, so that it became written as pi r L, okay? And total surface area can be considered as like the circle's area plus the sector's area, and we knew that here we have to add a new pi r squared, okay? So you want to find this curved surface area, that is pi r L, and you want to find the total surface area, that is pi r squared plus pi r times the length, okay? And for sphere, because that is just like a three-dimensional object and just rotated from a circle, right? Okay, so it just obeys two rules. First is a volume rule, because the volume here equals to 4 over 3 times pi times radius cube. And the surface area can be considered as the area equals to 4 pi times radius squared, okay? That is a sphere's rules, okay? And we can say that here is a hemispheres and this is a trap. And we can say that if you would only choose half of the sphere comes hemisphere, that the volume just divided into a half. Okay, so that is 4 over 3 times pi r cube, and then times r half. Okay, that is 2 over 3 pi r cube. Okay. So also you can say like the curved surface area only we have 2 pi r squared. Okay, that is a surface area like here because total is for 4 pi r squared. You only choose a half that is 2 pi r squared, right? And that the base area here is the radius, right? So it's pi r squared, okay? So we can say for the total surface area, that is 2 pi r squared plus pi r squared for a hemisphere, okay? That is 3 pi r squared, okay? And here's some deliberate practice for you. If you want to try yourself, you can pause the video and then do it yourself. But if you want to just follow with me, you can keep on going, okay? So let's move into the first part. It's a cone has a radius of 6 centimeter and a perpendicular height of 8 centimeter. Calculate the volume, okay? So you can say here that this is a cone and here's a radius 6, right? Okay, and the height is 8. So you can say follow the rules like 1/3 times pi r squared times height, right? That is 1/3 times pi times that is for 3 squared and then times sorry 6 squared because the radius 6 right here, okay? And the height is 8, okay? And you can see here that is 36, right? So 36 times 1/3 is 12. 12 times 8 is like 96, right? That is 96 pi, okay? That is a volume for first problem. And for second problem is that using the same cone, calculate the slant height, okay? And then the curved surface area, right? So we can say like here, radius 6 and the height is 8, and you can try to use the Pythagoras theorem to find the slant height, right? So the slant length here we can consider as right angles, triangles, uh, hypotenuse. So here is 6 squared plus 8 squared, right? That is for square root 100, right? So that is 10. So the length here is 10, right? Okay. So in this tab, we can say that the curved surface area can be expanded like a sector, right? Okay, this is 10. And we knew that for the base length, that is for like pi, 2 pi r, right? That is the base area for, sorry, base parameter for a circle, right? That is 2 pi radius, right? So here is 2 pi times 6, okay? That is 12 pi, okay? So you can just consider it as a triangle. That is a half times a height times a base, right? That is a half times the height 10 times a base length that is 12 pi, okay? So it can be considered as 60 pi, okay? And for third problem is that calculate the volume for a sphere with a diameter of 18 centimeter. Okay, please remember that here it's a diameter. Okay, so the radius for it is 9 centimeter. Okay, so volume can be considered as 4 over 3 pi radius cube. That is 4 over 3 pi times 9 cube. Okay, then you can calculate for the third problem. Okay, that's like the way to give it for you. Okay. And for fourth problem is that a solid wooden hemisphere it has a radius of 5 centimeter, calculate the total surface area, right? So maybe for this problem, we can set that for total surface area, first we have the half of the surface area, that is a half times 4 pi r squared, okay? That is 2 pi r squared. And then we have to plus the base area, right? That is pi r squared. That is 3 times pi times radius squared. That is 3 pi, then times 5 squared. That is 75 pi for the fourth problem, okay? And for fifth problem, we can say here, semisphere has a volume of 288 pi centimeter cube. If you want to find the radius right here, you can say that the sphere's volume that is for 4 over 3 pi radius cube equals to 288 pi, right? So you can first delete pi on the both side, and then you can just delete by 4 on the both side. So delete by 4, that is for 72, I guess, right? So we can set that r cube equals to 216, okay? So we can consider that maybe r equals to 6, that is 6 cube equals to 216, okay? So the radius here is 6 centimeter, okay? Always remember that the unit is very important, okay? So that is for today's our lesson. I hope you can understand for all the areas and the volume for how to calculate the cones and the spheres, okay? So see you next time. Bye.